Evet. Dinlemeyi de bileceksiniz. Okay. So this is actually Fourier transform is something similar to Laplace transform. You may recall from ordinary differential equation course. So if you have a function of t, then you can take its Laplace transform, and this becomes a function of s. And what was the formula? It was integral 0 to infinity e to the power minus st times f of s ds, I guess, right? So it converts a function of t into a function of s. And the nice thing about this, differential equations are converted into algebraic equations, which are easier to solve relatively. And then you solve that algebraic equation, and then you apply inverse Laplace to find the solution of the original problem. Of course, finding Laplace is easy. It is like derivative. You have some rules and you just apply the rules. But inverse Laplace is similar to integral, and therefore it is difficult. Okay, you don't have much rules. I mean, you have to just come up with some idea and think of functions whose Laplace transform is that one, and so on. So it's a little bit complicated. The same story is true for Fourier transform. It is another transform, but actually, technically, it is similar to Laplace transform. Okay, now idea is this. Suppose we have a function. Suppose f from R to R is a periodic function. Periodic function with period 2L. Then we know that then it has a Fourier expansion or Fourier series. F of x equals 1/2 times a0 plus from 1 to infinity an cosine n pi x over L plus bn sine n pi x over L, where this an's and bn's are just integrals from so I can write, actually it's like this, right? F of x cosine n pi x over L dx, and bn is just 1 over L minus L f of x sine n pi x over L dx. Okay. Now, and we use this to study wave equation or heat equation on a finite string or rod like this, right? Now, our aim is to take these two ends to infinity and study the same problem on the whole real line. And the idea is this. First, in this formula, let's plug all these values inside this summation and see what we get. So, çok yaşa. We have this. A0 is just 1 over L minus L f of x dx, because cosine 0 pi x is just 1. Therefore, I have no cosine term here. N equals 0 case. And then I have 1 over L summation from 1 to infinity. AN is just cosine, cosine, all right, let me use this. WNX and then minus L to L, f of P sine, cosine, sine, not sine, cosine, omega t dt plus sine omega nx integral f of t sine omega and t dt, where omega n is just n pi over L. Okay, so this is n pi t over L. Here you see x is a dummy variable, so I can replace it with any variable I want, right? I can just write t here. So that's what I did over there. Okay, t is a dummy variable, therefore I can just replace x with t. Onu evet. Okay, I forgot it. Daha doğrusu yazar unutmuş da ben de hatayı devam ettirdim. Neyse, o zaten ölecek birazdan. Okay. Let's look at the following. Note that Wn plus 1 minus Wn is what? It is n plus 1 times pi over L minus n pi over L. So it is just pi over L. Okay. So I can write the Fourier series then like this. And let me call this as, this gadget like this, delta W, the increment in W, and it is pi over L. So in this expression, let me, okay, put, pi here, all right. And this is now the, delta W, and it is independent of x and t, so I can just, take inside this gadgets and see, let's see what we have. This is just 1 over 2L. I will not touch this part because, as I said, it will die. And then I have 1 over pi here, 1 over pi. And then summation from 1 to infinity, 1 to infinity, cosine Wn x delta W minus L to L f of t cosine Wn t dt plus sine Wn x delta W minus L to L f of t sine Wn t dt. All right. And then what we will do, you see, this expression here looks like a Riemann sum, right? I have Wn's and the increments, and then I have summation. So this is a Riemann sum. Our interval is 0 to L. Yes. So what we will do is the following. We will just let okay, şöyle edeyim. Şurada da şuna dikkat edin. I will assume that this have this f is absolutely integrable, meaning that the absolute value of this function integrated from minus infinity to plus infinity will be a bounded number. Okay, so this number will be less than, let's say, 5. Okay, and then I will let L go to infinity. This is like 5, but L is going to infinity, so this term will vanish, and what we will have here is the following. So let me just write it down. This representation of f of x is valid for all fixed L, letting L go to infinity, because it is true for all L, so I just let L go to infinity and see what happens. And assuming this integral is finite, and oldu ama neyse, and we assume that this limit also exists. Yani sonsuza götürdüğümde L'yi aslında ne yapmış oluyorum? F'in sıfırdan so what I do, it was a periodic function between minus and L. I have this function and then it just repeats itself, but I just take this part from minus L to L and take this two numbers to infinity. So I just stretch the function between minus L to L to infinity. Yani eksi L arasındaki fonksiyonu sonsuza extend ediyorum, değil mi? So we had this function from L to minus L. We just take this ends to infinity, so we obtain a function on the whole real line. This is just stretched, I don't know, to infinity. Yani garip bir şey. Peki, ne olacak o zaman? Let's see what we get. This is just motivation. Actually, it is not a proof. we obtain, şöyle bir şey çıkacak. F head of x. So this f this f converges to that function f bar x. This term will vanish because this integral is finite for all L. I mean, it's finite and a fixed number. It is always less than a constant number, but you let L go to infinity. So this will just die. And here, this will turn out to be an integral. Now, so what will be the integral? Integral will be the following: 0 to pi, integral 0 to infinite, cosine omega x minus infinity to plus infinity. Değil mi? 50 sonsuza götürdük. Burası bizim increment'ımız wn'di. Dolayısıyla variable'ımız w oldu. F of t cosine omega t dt plus sine omega x f of t sine omega t dt. And then here I have dw. Delta w işte dw oldu. Yani o Riemann sum'ı integral olarak yazdık. Tamam mı? Şu katsayılara bir şey olmadı. Nothing happened to this coefficients except the boundaries went to infinity. And this is just, you know, wn delta w. So this became integral of w cosine wx dw. And the boundary of the integral, so this wn is just this. So when L goes to 0, I mean infinity, so it was starting from pi over L. Pi over L goes to 0, and then you know, till infinity. Peki. Bu ifadenin bir ismi olacak. Biz buna şey diyeceğiz. Yok, x'i orada sabit gibi görüyoruz. Her x. Yani şurada we regard x as a constant here in this formula, right? We regard x as a constant here. N is changing. Wn is the increment, which is pi over L, and then I have this sum. I regard this as a Riemann sum. Yani tabii bu ispat değil, dediğim gibi. Hani sadece motivation, şeyi motivate etmek için. Şöyle diyeyim. Definition. Let f minus infinity plus infinity into R or C be a function. The Fourier transform we abbreviate it as ft of f of x is defined by şöyle Fourier transform of f. This is a function of w, okay? It's like Laplace transform. In Laplace transform, we had a function of t. Its transform, Laplace transform, became a function of s. Here, this is a function of x. Fourier transform is a function of w. And it is what? It is just this number 1 over 2 pi minus infinity to plus infinity f of t e to the power minus iwx dx, provided that the integral exists. Bununla şunun alakası nedir? Onu da isterseniz açıklayayım. Remark, hani what is the relation between this formula and this formula? It is the following. Şöyle yazarsak şunu. Okay, so here you see this is just 1 over pi, 0 to infinity. I have f of t is constant, right? Here, actually, just let's, okay, minus infinity to infinity. Take this cosine wx and sine wx inside the integrals and write this as a single integral and take into cosine parenthesis, ft parenthesis. Then I have cosine wx times cosine wt, sine wx, sine wt. So this is just cosine wx minus wt. Değil mi? Wt, and then I have dt, and then we have dw. Okay? Efendim? Double integral oldu. Zero'dan sonsuza, burada da eksi sonsuzdan artı sonsuza. Peki sonra ne yapacağız? Well, this is something similar, right? Onu da şöyle yazabiliriz. This is just e to the power I, this gadget, right? Wx minus Wt plus e to the power minus I Wx minus Wt, right? If you open these up, you have cosine of this plus I times sine of the same thing. And here this is cosine of this, this term minus I times sine of this. Sine terms will be cancelled. So I need an extra 2. Yeah. So we just need to put, if I write this, okay, so divided by 2. So buradan da ne çıkar? Şöyle yapayım. So f tilde x is just, şunu şuraya yazdım. 1 over 2 pi, 1 over 2 pi, 0 to infinity, and minus infinity to plus infinity, f of t, and then e to the power I wx minus wt minus no, not minus, plus e to the power minus I times wx minus wt, okay, dt, dt and dw, both of them. Okay. Bunu iki ayrı integral gibi yazalım. Şöyle 1 over 2 pi 0 to infinity minus infinity to infinity e to the power t e to the power minus wx minus wt dt dw, and then plus 1 over 2 pi 0 to infinity minus infinity plus infinity f of t e to the power minus minus I wx minus wt dt dw. Şimdi şöyle bir üçkağıt yapacağız. W'yu in this integral, let's replace w with minus w, okay? If you do that, so if I plug minus w for w, this will be plus. This will be minus, right? There will be a minus sign because I am replacing w with minus w. So dw becomes minus dw. So I have a minus sign. But here also, this will this time become from minus integralin bu w, so here w was ranging from minus infinity to plus infinity. If I replace with minus, then it becomes from an integral from infinity to minus infinity. O değişmeyecek. Özür dilerim. I am sorry. This will not change. Sorry. Minus infinity to plus infinity. So this will become minus infinity to 0. Okay, but this minus sign also will just invert it also, this integral. And then I can make this plus and bunu da sıfırdan eksi sonsuza. Ama yok. Zaten böyle olsun istiyorum aslında. Tamam. O zaman bu gitti, değil mi? Tamam. Şimdi ne oldu? Let's see what we have. We have the same stuff here, right? They are the same. These are the same. This is from minus infinity to 0 and then 0 to infinity. So this whole thing adds up to just integral. I can just take one of them and this becomes from minus infinity to plus infinity. So it becomes this. Çektin mi? Tamam, şöyle. So we have this. Minus infinity. Both of them are minus infinity. Şu şey de şöyle yapmış. Bunu da şöyle yazıyor. 1 over square root of 2 pi minus infinity to plus infinity e to the power I wx and then 1 over 2 pi in square root minus infinity to plus infinity f of t e to the power minus I wt dt and then dw. Bir dakika. Ha, şurada bir teorem var. Onu ben söylememiştim. Onu söylemek lazım. Neredeydi o? Ha, e, okey. Şöyle bir teorem var. Teorem şu. If f of x is piecewise piecewise continuous on every bound interval of r, and this integral, pardon, şu integral is bounded, uh, then uh, bu f hat of x is equal to f of x. Whenever at the points where f is continuous and f of x is just fx plus fx minus over 2. Average at the points where f is not continuous. Yani şunu söylüyor. Bu şekilde tarif ettiğimiz fonksiyon, şimdi f buna eşit, right? F is equal to this gadget, but still actually at the point where f is not continuous, you don't have equality, right? You have something like this if you recall from Fourier series. When we take the limit, this became f tilde, and we wonder whether this function is the same as f. And this theorem tells us that actually it is the same, provided that, you know, this condition, which kills the a0 term. And at the points where it is not continuous, so f is something like this. This is a bounded function, piecewise continuous. So we may have jumps like this. And at such points, f tilde is just the average value. So this is f head of x. Average of these two values. Yani this is right limit, this is left limit, okay? But this tells us what? You see, nereden çıktı? So we have the following then. You see, we had this f tilde, right? We have this f tilde written like this. This is equal to f of x. F of x. I mean, if the conditions of the theorem are satisfied, f of x is equal to this gadget. And what we call, you see, you have basically the same operation applied twice. You multiply f with this function, integrate from minus infinity to plus infinity. You obtain a function of w, and then to this function, you multiply with this gadget and integrate from minus infinity to infinity with respect to w with the same coefficient here, and you get back to f of x. So this is an operation. We will call it Fourier transform. Fourier transform. And this operation here is just the inverse Fourier transform, so that when you apply these two operations back to back, you get back to f of x. Tamam mı? Şeye de, o öbürüne de işte inverse Fourier transform diyeceğiz. Yani so Fourier transform is this. You have f minus infinity plus infinity into r, or c. Fourier transform of f is a function of w. Evet, ben biraz notasyonu karıştırdım ama neyse, tamam, sorun değil. Buna 1 over 2 pi diyeceğiz. Minus infinity plus infinity f of x e to the power minus I w x dx. Here w is between minus infinity and infinity. And then inverse Fourier transform. It is this one. Efendim? Şu işte o. Yok yani bu hale dönüşmedi mi zaten? Yani şuna Fourier transform diyoruz. E, tabii bu dummy variable, yani ne koyarsanız koyun, çok sorun değil. O. Burada x demem lazım da ondan. I'm sorry. So yeah. Yeah, here in this definition I have x here, not t, of course. Otherwise it is useless, right? You can just take f of t outside and no. Oh, sorry. Here I had wrote t, but it's of course not correct. It should be x. Okay. This expression and this expression are the same. T here is a dummy variable. You can put anything you want. Değil mi? Ahmet koyun, Mehmet koyun, aynı şey. X yerine ne isterseniz koyun. So what is this? Inverse Fourier transform. Ben biraz notasyonu da karıştırdım da buna F tilde diyeyim. Yani kitap F hat diyor. Bu F hat tabii öbür F hat'le aynı şey değil. Neyse. Okey. Şöyle diyeyim. F tilde diyeyim. F tilde bu F x olacak. So this is F tilde of W. F tilde of W. This becomes just F of X. So it is just 1 over 2 pi minus infinity to plus infinity. This time we have F head of W I W X dW. So this integral e to the power IWX dW. Zaten oradaymış kamera. Okay, so inverse Fourier transform is just this gadget. Okay. Örnek yapacakmışım gibi pek gözükmüyor. Yani şeyleri söylemem lazım. Bunun türevlerle ilgili koşullarını. İsterseniz onları yazayım. Ama hani şey yapamayacağım. So let's just write down properties. It is linear, right? I mean, if you have f plus g, then of course this is just f plus g, or some constant times f is just c times f. It is linear. What else? What else? Şöyle bir convolution şey var. Convolution. It's like Laplace transform. If we have two functions, then their convolution is defined to be this. This is the convolution. Okay, convolution of f and g. And the relation between convolution and Fourier transform is this. It's like Laplace. If you have two functions and Fourier transform of the convolution is just the product of the Fourier transforms. Okay. And the proof is just similar to what we have seen in ordinary differential equations for Laplace transform. The same proof. Okay. So it's not something new. we have so-called Parseval's identity. Yani bu da önemli bir şey. Şunu söylüyor. Minus infinity plus infinity f of x gx dx minus infinity plus infinity f tilde w g tilde w. Bunlar ya da şöyle diyeyim, hani Fourier transformlarını yazayım şuraya. Yani iki fonksiyonun absolutely integrable iki tane fonksiyonun çarpımının integrali. We may regard this as an inner product on functions, absolutely integrable functions. And this tells us that the inner product between these two functions is preserved under Fourier transform. Now, these are functions of w with respect to w. Okay. So Fourier transform preserves the inner product. So it's an isometry on the well, izometri mi bilmiyorum. Çünkü başka bir uzaya gidiyor olabilir. Ya ama inner product'ı koruyor. Yani öyle söyleyebiliriz. Tabii bunlardan ziyade bizi ilgilendiren kısmı bunun türevlerle olan alakası. Onu söyleyelim. Şimdi şey yazarsak Fourier transform'un tanımını. So if u is a function of x and t, then Fourier transform of u, which is a function of w and t, right? This x becomes w, and it is just this expression, 1 over 2 pi in absolute, in square root, minus infinity to plus infinity, u x okay, uxt e to the power minus I w x dx. Yani şuradaki t buradaki t değil. So what was our definition? Here it is the definition. Instead of f, I have uxt. Okay, so function of two variables, right? This is the definition of Fourier transform. And then we do the following. Okay, now u sub x'inkini hesaplamak istersek u sub x. So this is 1 over 2 pi minus infinity to plus infinity. Here I have u sub x xt e to the power minus iwx dx. Okay. How would you integrate this? Well, we apply integration by parts. So this is 1 over square root of 2 pi. And then integral of this, which is just u xt e to the power minus iwx, right? From 0 to, not 0 to, minus infinity to plus infinity. Yes. Burada şey koşulu olacak. Efendim? Şöyle diyeceğim, tamam. Orada plus ya da minus 1 over 2 pi minus infinity to plus infinity u x t, and then derivative of this gadget, derivative is just e to the power minus I w x dx, but I times minus I times w comes down. And then we assume the following, we make the following assumption. Şunu da yazayım, bırakacağım. Yani burada istediğim yere gelemeyeceğim. O yüzden muhtemelen buradan soru sormam da. Gene de şöyle bitirelim. So, if we assume şu koşulları u x t goes to zero and u sub x xt goes to zero. Bu da çok aslında aşırı bir koşul değil. Neden? Ya aslında şuna gerek yok. Neyse. Şuna gerek bile yok aslında. Bu koşul çok şey değil. Neden? Şu integralin finite olmasını istiyoruz ya. Yani eksi sonsuzdan artı sonsuza kadar bu integral finite. Bu da ne demek? Bu fonksiyon, so we assume that this integral is finite. Therefore, the graph of this function with respect to x, I mean, considering this as a function of x, t is like a parameter. This integral is finite means this function, should go to zero, right? Otherwise, I mean, this wouldn't be finite. Therefore, actually, this condition is not something, too strong in our case. And in that case, what happens? So when you let x goes to infinity, this gadget goes to zero. And this gadget, as x goes to minus infinity, it also goes to zero. Bu ifade ise şey, this is sine and cosine, basically, right? They are bounded by -1 and 1. Therefore, this will not affect anything. Therefore, this gadget will go to zero, and I will have just this, and this minus sign will give us plus, and what we will have is this. So, so we will have the following, and thus we obtain Fourier transform of u sub x as a function of w and t is just I times w Fourier transform of u. This IW comes in front. This became plus. This term vanishes. So what you get is just Fourier transform of u back again, right? Yine u'nun Fourier transformunu elde etmiş oluyoruz. Therefore, for a function like this, derivative with respect to x Fourier transform is just equal to this gadget. Fourier transform of u multiplied with this number. Well, if I apply this one more time, this time I will assume also this guy go to zero because, I'm taking derivative one more time. So we should work with such functions where all the derivatives also goes to zero. So I will just multiply this expression one more time with IW. So IW squared f sub u, f of u. Efendim? Yani her türevini aldığımda bu değişmiyor. Sadece IW ile çarpıyorum. So minus W squared FU. Buradan da ne çıkacak? So you know, so the functions of U are converted into yani şöyle bir şey olacak. Şunu yazayım. Orada bitirelim. Yani bunları yapabilmeyi umuyordum ama. Yani elimizde şöyle bir heat equation varsa application diyeyim. PDE U sub t x t alpha squared U sub xx xt x is between minus infinity plus infinity and t positive and initial condition u x0 equals f of x. O zaman işte şu olacak. Bu denklemin Fourier transformunu alırsam, if I just apply Fourier transform to this equation, Fourier transform of u sub t is just alpha squared times Fourier transform of u sub xx. This gadget is just bu tamam. Şurası şey olacak. Alpha squared, bunu compute ettik. Minus w squared Fourier transform of u olacak. Şunlar şöyleydi. Şu nedir? What about this one? Fourier transform of u derivative. Well, you see, here if I write derivative of u, then I need to take derivative with respect to t, right? Derivative with respect to t. So you just take derivative with respect to t. Nothing will happen here. So derivative with respect to t, this Fourier transform is just dt of Fourier transform of u. So what you get is just minus alpha squared w squared Fourier transform of u, and then here I have Fourier transform of u, but the derivative of it. Yani ne elde etmiş olduk? So we obtain a first order ordinary differential equation. This is our variable function, whatever it is. Its t derivative is just minus alpha squared w squared f of u. And actually, you know, we can just solve, right? Fu is what? Which function has this property? E to the power, right? E to the power minus alpha squared w squared. So what is u then? U is just inverse Fourier transform of e to the power minus alpha squared w squared. T de var, evet. Dolayısıyla çözümde işte bu fonksiyonun, bunun tabii bu w'nun, this is the function of w, right? And t, but here we regard t as if it's a parameter. As a function of w, we apply f inverse and we obtain, we replace in that case the variable w to x. So we will obtain a function of x and t. Neyse yani bu kadar. Efendim. Hı. Ha bunu söylemedik. Bunları konuşmadık. O işte ben size türev almayı gösterdim. O integral. Hani o kazık.